So here we start to discuss the process capability measurement. Eventually, I'm going to introduce a series of process capability indices that can tell you what is the current level of performance for your process. Whether the process talk about your manufacturing process or service process, it can tell you whether it will generate substantial amount of defects or not. We studied this in 3020 a little bit, and I'm going to offer more explanation on this theme. But before we dive further, I'd like to show you a simple example here. On my hand, I'm holding 3 bottles of Costco water. I think you all expect that from bottle to bottle, the water level should not be too different. Okay, you're expecting that all 3 bottles will have same amount of water, which is 16.9 fluor ounce. But just by visually inspecting this, I can tell that the one in the middle has a slightly higher level of water. You can observe that in many consumer goods, not only in the drinks, also in the peanut butter. I've been using peanut butter, for example. Maybe some other things like a calculator may look the same size, but when you measure using the with some precise machine measurement tools, you may see that from calculator to calculator, they may have slightly different thickness or things like that. So in other words, the outcome from a process can be random. Okay, because it's random, therefore it is very important for us to know what is the likelihood that your current process will generate that is bigger than the specification limit or smaller than the specification limit. We'd like to know what is the proportion of those defects on upper and on lower end. Okay, so we typically do process capability study in order to determine what is the current process capability. Okay, so in order to answer these questions, the reason why we do process capability study is because we'd like to learn these things. Where is the process centered? Again, I said the process usually is random. Therefore, you can use a distribution to capture the shape of its outcome. So you'd like to know where is the middle. You also like to know what is the variability. You'd like to know what is the standard deviation. This is what it's saying, right? What is the performance relative to specification limit acceptable? Is the performance relative to... This is one thing that's very important. If your specification limit is here, right? Spec limit is here, means all these things will be considered as a defect, which is huge. So we'd like to know what is the size of these areas outside of the specification limit. What proportion of output will be expected to meet specifications? That means what is the proportion before it gets to the specification limit, and what factors contribute to the variability. When you have a large variability, this is what a process look like. When you have a little variability, this is what the process is look like. So the simple question, which one do you prefer? This type of process or this type of process? 1, 2, 3. Okay, I think rationally we'd like to have process with a smaller variability because things are more even, therefore it is more easier to control. Okay, and let's take a look. So how do you do this type of study? I'm not going to ask you to design a study, but this is a typical process. So there are some important information here. Choose a representative machine and operators. Okay, don't pick best operator and the best machine. Just pick something that is representative. Define the process conditions and prepare sufficient standard grade materials. Also, you're looking at a standard grade materials. You also want to have them sufficient so that your study won't interrupt in the middle because you're running out of supplies. Okay, and you're determining the gouging and measurement method to be used, and determine the sample size. So in reality, when you do a lot of sampling in the manufacturing process, you don't use as much samples in. But in here, in order to study the true capability of your process, we typically recommend to use a very large sample, typically larger than 100, even it costs money to do so, okay? Because the true capability is something truly, truly important. Again, the objective of the study, one thing you'd like to understand the characterization of the study. What is the average? What is standard deviation? What is the shape? And then we'd like to study the peak performance of the study. And we also like to study the component variability study. What contributes to the variations? So that takes us back to the chapter 6 contents, those experiment design. It's when it will happen. But our focus in this particular chapter is actually the first one here, process characterization study. So let's take a look at the first example. This is a U-Bolt data. I will attach this data under the video. You can play around yourself, see if you can obtain exactly the same result as mine. And to identify its process mean, of course, you can do this easily using the average formula. And then the standard deviation, you can use STDEV.S. Do not use P, as that is the calculation for the population. They use different formula. The standard deviation of the population, standard deviation for the sample is different. You need to always use S for this type of study. And the shape of the distribution. So this needs to draw the histogram. But first, identify the range of the process. So range of the process. So it looks like it is asking what is average, what is standard deviation. It should be answered here. And the specification is this. So what proportion will be outside of the range? What is the DPMO? So let's take a look.